Hello guys, so this is team Q's to use for the subject of network science in Spring 2022. Our team members are Raghav, Shefali, and Tanay. Introduction, words are one of the most fundamental components of today's world, and it is fascinating to watch how some words are recalled when given a specific term. So if a person is given a specific term, he or she maps it to his or her experience or memory and then recalls certain words. And this study of how these words connect to each other is something that is interesting and something that we want to dive deep into in future. Uh, what is our motivation for this project? So we basically want to learn why people remember just those specific words when given a cue word in a specific context, and what is the important problem that we are tackling. So the problem that intrigued us was, can we analyze features of words that recall these certain words, and can we know what are the qualities of these words that they possess? What is our proposal? We want to use the data to deep dive into the links between the cued words and the recalled words using network notions like centralities, communities, etc., to see how connections are made and formed. Furthermore, grouping these words into discrete topics, subtopics, or parts of speech, and establishing links between them will aid us in comprehending a broader relationship between them. This is how our data set looks like. It has columns of Q target normed, number of words in a group, participants, the forward score, backward score, and the Q part of speech and the target part of speech. So there are certain constraints that we had decided upon for our data set, and those are as follows: that we filtered out the data to have no backward score or backwards trend, which means the target word cannot hint towards the Q word. All records are valid and normed. The parts of speech that we selected for this particular project was just nouns, verbs, and adjectives, since these had the most records. And there will be minimum of 3 people who will be responding to a certain Q target pair. Furthermore, we also are using part of speech tags of the Q and target words to deep dive into their association.
So here are a few methodologies which we tried to implement in our data. So the first one was part of speech tag. The second one is vowels association. The third is subtopics association, and the last one is topic association. So in those above method, we removed few records which were kind of incomplete or having null values, and we used the former strength mean value as the age of the weights. Next slide, please. Okay, so for the part of speech tag, we tagged the Q and the target word with the part of speech. And using these tags, we tried to create a network for Q and target network, and we visualized them in Jeffrey. Furthermore, we pre-processed the data and we were able to see, like on the right hand side, you can see the prominent tags are noun, verb, and adjective. And we removed few negligible tags. Furthermore, we assigned the weights of the ages as the mean of the forward strength. And we can see that here adverb is having a really strong association with the prominent tags. And it can also be observed that the data is highly imbalanced, and maybe our observations can be biased towards it. Next slide, please. Okay, the second approach is vowel association. So the keywords are exclusively assigned with vowels as the initial letters, like A, E, I, O, U. And this is done because the data set is quite huge, and those specific words gives a proper association to few other words. So we created a network on Gephi to get more better insights from it. Here you can see that the data is highly discrete, and the data is highly discrete. And on the next, can you switch to the next slide, please? Yeah, so here in the vowel association, you can see like we have taken the word work. It is not a cue word, but the words are, uh, it is not a cue word in the vowel association, but we can see that it is a betweenness center with all the other words. Next slide, please. Uh, here, our in the vowel association, we can see like endless has the highest betweenness property, although the number of numbers for it is considerably less. Next slide, please.
Going into the subtopic association, we used this because we found that the Q target words was quite high, So what we did was we took the superlative of the Q and target words, which are called hypernyms, and then we formed a network using them. So using subtopics kind of generalizes the networks. So as you can see, we have just 2154 nodes, and we use the weighted edges and we use the betweenness centralities and communities to gain more insights. So you can see in this network that there are a lot of words which are highly associated or strongly associated, but they're not the betweenness centers. Next slide, please. So you can see that I've taken a subtopic property, but you can see that it's weakly associated with all its neighbors. But since it's one of the betweenness centers, the number of neighbors is quite high. Next slide, please. Another example which we took was oppress. You can see that it's strongly associated with all its neighbors based on its forward strength weights. But you can see that although it's strongly associated, the number of neighbors is quite low, which could give us more insight as to how this network is being formed. Next slide, please. Another association which we did was topic association, which we did in the same method as subtopic, but we also took the superlative of subtopic to more generalize it more. So we can see that we have only 1185 nodes, and we use the same like directed graph, communities, and weighted edges. Here we can see like it kind of follows a scale free network. And moving on to the example standard, so we took a example called standard, and we can see that it has a mix of strong association with its neighbors and weak association too. So, and its number of neighbors is quite high too. It could say that it is a scale-free graph where it's connected and it's being a small world. Moving on to the next example, we have the message where you can see it's one of the betweenness center and it's highly connected to majority of the nodes and across different communities too, which suggests that it's a highly scale graph, it's a scale free graph, and could be an ultra small world too. Next slide, please. So from the all four methodologies, we can conclude that in the part of speech tagging, there is strong relationship between the three main prominent parts of speech, which are noun, words, adjectives, but there's not enough data which could say more about it, hence it could be biased. And that the vowels association network is follows a heterogeneous network and a sparse network. And in the subtopics association, we saw that some nodes have very strong association, but overall they have very less neighbors. In the topics association, it follows a scale-free graph, which is the small world, or it could follow an ultra small world too, because as it's generalized too much. Next slide, please.
So here are a few limitations and future scope which we thought about. So the primary limitation which we faced was visualizing and analyzing such high number of node and edges in a tool like Cafe. Another limitation was the data acquisition of highly relevant data sources to map the features in the current data set. For the future scope, we entail on application of machine learning models to predict that the target words on the keywords, and maybe we can include some features like the sound of topic modeling and some application concepts like community detection and more. Next slide, please. So here are some citations and references which we use throughout our project. Next slide, please. Thank you.